How much consideration have you ever given to the content of the air you breathe? How much oxygen is in it? The answer is around 21%, but most healthy people really don't need to worry about it. To some clinical patients, however, the oxygen content of the air they breathe is crucial to their health. Oxygen therapy is not a new or a particularly revolutionary treatment, but implementing that treatment in the developing world in an effective way presents its own set of unique challenges. Hi, I'm Paul Gordon from the University of Cincinnati's Biomedical Engineering program, and I represent the Zeolife team. Solving those challenges is what our project is all about.
Oxygen therapy can be essential for a variety of patients, including neonates, post-operative patients, and anyone with respiratory complications. These patients can frequently suffer from a deficiency of oxygen in the bloodstream called hypoxemia. In order to return to a healthy level of oxygen in their bloodstream, patients must breathe a higher concentration of oxygen than the 21% found in the atmosphere. The World Health Organization also includes oxygen on its list of essential medicines, and one of their 2010 reports showed that only 44% of health centers surveyed in 12 African countries had access to oxygen on a regular basis. We believe that this trend extends to low-resource settings around the world, indicating a large gap in the healthcare provided and a tremendous opportunity to improve patient outcomes.
Oxygen concentrators are a practical method to deliver oxygen to patients in the developing world because they can provide an indefinite supply of oxygen given a reliable source of electricity. Our team traveled to Guatemala in December 2014 to better understand how oxygen concentrators are used and verify the various ways they can fail. We worked with several rural clinics and a medical supply distribution agency to assess these challenges. We found through our research and travel experience that the hot and humid environments typical of low-resource clinical settings accelerate the contamination of the zeolite filter material found in oxygen concentrators. This contamination leads to a decrease in the machine's oxygen output, a problem that can be detrimental to the patient.
Our solution focuses on developing a device to remove contaminants from the zeolite filter material in order to restore the oxygen concentrator efficiency to acceptable levels, thereby extending the lifespan of the concentrators in these low-resource environments. We are currently refining the zeolite decontamination process using small samples and are constructing a prototype to transfer this process to a larger scale. A single device will be usable on multiple concentrators, putting many deficient machines back into use, and providing clinics with a more affordable and sustainable source of oxygen therapy. We believe that this technology can improve patient health. Our goal is to see it fully developed and implemented in healthcare facilities around the world.